Imagine discovering that everything you can see in the universe is almost nothing. Every star, every planet, every galaxy, every glowing cloud drifting through space. All the ordinary matter we know may make up only a tiny fraction of what is really out there.
Because the truth is far stranger than science fiction. The universe appears to be filled with something invisible, something that does not shine, does not reflect light, and does not reveal itself directly to our eyes or telescopes. And yet it may be controlling the structure of the cosmos itself.
Scientists call it dark matter. And if dark matter is real, then the galaxies we admire in telescope images are only the visible surface of a much deeper hidden reality. Tonight, we are exploring one of the greatest mysteries in science. What is dark matter? How do we know it exists if we cannot see it? What is it doing to galaxies, clusters, and the entire cosmic web? And what would happen if it suddenly disappeared? Because dark matter may not just be part of the universe, it may be the invisible framework holding everything together. What is dark matter really doing to the universe? Chapter 1. The Galaxies That Should Not Hold Together. At first glance, a galaxy seems simple. Billions of stars orbiting a bright center, all bound together by gravity.
But when astronomers started measuring how galaxies rotate, they found something deeply unsettling. The stars near the outer edges were moving far too fast. According to the amount of visible matter in those galaxies, those outer stars should have been moving more slowly.
In fact, many of them should have been flung out into space long ago. But they were not. They stayed in orbit. Which meant one thing. There had to be more mass there than anyone could see.
Something invisible was adding gravity. Something massive was surrounding galaxies in vast hidden halos, keeping them from flying apart. And that was the first major clue that the universe was not made only of the matter we can detect.
Chapter 2. The First Signs of Missing Mass. This mystery did not begin with spiral galaxies alone. Back in the 1930s, astronomers studying clusters of galaxies noticed that entire galaxy groups were moving too fast to be held together by visible matter. Once again, the math did not work. There was not enough glowing material to explain the gravity being observed. It was as if the universe kept whispering the same warning over and over again. You are missing most of the mass. At first, that idea seemed unbelievable. Maybe the observations were wrong. Maybe the calculations were incomplete. Maybe astronomers were overlooking faint ordinary objects. But decade after decade, the evidence only grew stronger. Galaxies rotated too fast. Clusters held together too tightly. Light bent more than visible matter could explain. And slowly, the idea of dark matter became impossible to ignore. Chapter 3. How do you see something invisible? Dark matter is not called dark because it is black or shadowy. It is called dark because it does not interact with light in any detectable way. It does not glow. It does not reflect light. It does not absorb light the way normal matter does. So if it is invisible, how do scientists study it? By watching what it does to everything else. Dark matter reveals itself through gravity. It affects how stars move through galaxies. It shapes the behavior of galaxy clusters. And perhaps most dramatically, it bends light itself. This is known as gravitational lensing. When light from distant galaxies passes through a massive object in the foreground, that mass can warp space-time and bend the light behind it. Astronomers can actually see background galaxies appear stretched, warped, and distorted because of mass in front of them. And here is the key detail. Sometimes the visible matter is not enough to create the lensing we observe. There must be extra mass there, invisible mass, dark matter. So while we cannot photograph dark matter directly, we can map its influence by watching how it reshapes the universe around it. It is like seeing the wind by watching trees bend. You cannot see the force itself, but you can see exactly what it is doing.
Chapter 4: The Bullet Cluster. One of the most famous pieces of evidence for dark matter came from a violent collision known as the Bullet Cluster. Two enormous galaxy clusters crashed through one another in deep space.
Now, ordinary matter in galaxy clusters often exists as superheated gas, and when those clusters collided, that gas slammed together, slowed down, and was left behind. But when astronomers mapped where most of the gravitational mass was, they found something shocking.
The majority of the mass was not where the hot gas was. It had moved ahead. In other words, the visible matter and the main gravitational mass had separated. That was a huge moment in cosmology,
because it suggested that much of the mass in those clusters was not ordinary matter at all. It behaved like a separate, invisible component, a component that passed through the collision with much less interaction, a component that looked exactly like dark matter. The bullet cluster became one of the strongest visual clues that the universe contains far more than the atoms we know.
Chapter 5: The Cosmic Skeleton. Now zoom out even farther. On the largest scales, the universe is not random. Galaxies are arranged in enormous filaments stretching across space, connected in a giant cosmic web. Between those filaments lie vast, empty voids.
This structure is so immense that it is hard to comprehend, and many scientists believe dark matter played the central role in building it. In the early universe, tiny density differences existed everywhere. Regions with slightly more mass pulled in more material over time. Dark matter, because it does not interact with light the way ordinary matter does, may have begun clumping early, forming the invisible gravitational scaffolding of the cosmos. Then ordinary matter fell into that framework. Stars formed, galaxies formed, clusters grew. If that picture is correct, then dark matter is not just an extra ingredient in the universe, it is the hidden skeleton beneath everything we see. The bright galaxies are only the glowing decoration. The real structure may be invisible. Chapter 6: What dark matter is not. Could dark matter just be ordinary stuff we have failed to notice? Maybe clouds of cold gas, maybe dim stars, maybe rogue planets, maybe black holes scattered through space. Scientists considered all of these ideas, but the evidence suggests ordinary matter is not enough. There simply is not enough normal material, even hidden normal material, to explain the gravitational effects being observed across the cosmos. Dark matter also is not the same as dark energy. These two are often confused, but they are very different mysteries. Dark matter appears to help hold structures together through gravity. Dark energy is the name given to whatever is causing the expansion of the universe to speed up. One helps explain why galaxies stay bound. The other helps explain why the universe as a whole is expanding faster and faster. Both are mysterious, but they are not the same thing. Chapter 7: The Hunt for the Particle. If dark matter is real, then what is it made of? That question has driven one of the biggest scientific hunts in modern history. Many physicists suspect dark matter may be made of entirely new particles beyond the Standard Model. One famous idea involved particles called WIMPs, weakly interacting massive particles. Another major candidate is the axion, a hypothetical ultralight particle. There are also theories involving sterile neutrinos, primordial black holes, and hidden dark sectors with their own strange physics. To find answers, scientists are searching in three major ways. First, they try to create dark matter in particle colliders by smashing particles together at enormous energies. Second, they build ultra-sensitive underground detectors, hoping a dark matter particle passing through Earth might collide with a nucleus and leave a tiny signal. Third, they search the sky for indirect evidence, looking for unusual gamma rays or other particles that might come from dark matter interactions in space. So far, none of these efforts has given a final confirmed answer. That is what makes this mystery so powerful. Dark matter is not just a theory in search of evidence. It is evidence in search of an identity. Chapter 8. Or is gravity itself wrong?
There is another possibility. What if dark matter does not exist as a particle at all? What if our understanding of gravity breaks down on the scale of galaxies and clusters?
Some scientists have explored theories of modified gravity, trying to explain these strange observations without adding invisible matter. That is a serious scientific idea, because good science must test every possibility. But dark matter remains the leading explanation for one big reason. It helps explain many different observations at once: galaxy rotation, cluster behavior, gravitational lensing, large-scale structure, the cosmic web.
To replace dark matter, any alternative theory has to explain all of those things just as well or better. So far, that has proven extremely difficult, which means the invisible matter explanation still stands as the best overall model we have. Chapter 9. What if dark matter disappeared? Now imagine the impossible. What if dark matter suddenly vanished from the universe? The results would be catastrophic. Galaxies that seem to rely on dark matter halos for much of their gravity would be fundamentally altered.
Outer stars would no longer move the same way. Clusters of galaxies would lose huge amounts of the mass keeping them bound. The cosmic web itself would no longer resemble the giant structure we observe today.
And perhaps most important of all, the universe may never have formed the same way in the first place. Without dark matter, galaxies might have formed more slowly, less efficiently, or maybe not at the scale we know at all.
In other words, the shining universe may exist in its current form only because something invisible shaped it first. That is what makes dark matter so extraordinary. It may be one of the most important ingredients in reality, even though no human has ever directly seen it.
Chapter 10. Why this mystery matters. Dark matter is not just a distant astronomy problem. It is a reminder that humanity still does not know what most of the universe is made of. Think about that. We have split the atom, walked on the moon, mapped galaxies, detected gravitational waves, photographed black holes. And still, when we ask what most of the matter in the cosmos actually is, the honest answer is, we do not know.
That should not make the universe feel smaller. It should make it feel bigger, stranger, more alive with mystery. Dark matter tells us that reality is deeper than our senses.
The visible cosmos feels complete only because our eyes were never designed to see the full truth. Science is our way of reaching beyond those limits, of building instruments, ideas, and experiments powerful enough to reveal what nature keeps hidden.
And dark matter may be one of the greatest hidden truths of all.
Look up at the night sky, and it seems full of light. Stars burn across the darkness. Galaxies glow at the edge of human sight. But the deeper reality may be far more astonishing.
The universe we can see may be built on a hidden foundation, an invisible gravity, a silent structure, a cosmic skeleton wrapping itself around every galaxy in the sky.
Dark matter may be holding galaxies together, shaping the cosmic web, bending light across billions of light years, guiding the growth of the largest structures in existence. And yet, even now, we still do not know what it truly is.
That is what makes this one of the greatest mysteries in science. The universe is still hiding something enormous from us, and one day, when humanity finally uncovers the truth, it may transform physics forever.
If you enjoyed this journey into the invisible universe, subscribe to Infinite Science, because there is always another mystery waiting beyond the edge of what we can see. And until next time, keep looking up.